Okay, recently I was looking at the mask for pictures I can look at, compare one to the other, and I found that the Antennae galaxy up here had some pictures over here on the side here where the mouse is that I could use to compare one to the other. It had a good background view with no foreground interference. And so I went ahead and downloaded them, and I thought, well, I could try a Python program to compare see if I can compare them. So what I did was, let's see if we can get this to stop here. Started it. So the original program I got off off the internet to see if we can compare one to the other and to detect movement. And turns out this is not the best way to do it. So now, this is comparing like 10,000 stars locations from one photo to the other. And that's where all the little green dots are. And the second video is it's making a connection from one point in the graph to the other. Obviously it's spaghetti and it didn't work right. So, and this is basically the same photo. I don't know why they did that, but anyways, the program we can find online and fairly easily to implement in PyCharm. But I found the best way to do this is to just download all the images and compare one to the other. So I did this in photo and sorted them by time, or yeah, by image, and each image is like 5 to 20 minutes apart. So if I look at like the first image and compare it to the second image, obviously you can see some spots like right here. I do one and the other. That's just one little spot, but there's a ton of them here. And like this spot in one photo, that spot in another photo. Like this spot, one photo, and that's not what I want. From flicking back and forth, you can see the movement. Some things move, like right here, this spot, here, but the first photo, it's over here. And it turns out like this, that there's photos like this taken by the James Webb Space Telescope show there's a ton of space rocks out there. You can go to a different one here. You can click back and forth, and you can see the movement from one exposure to the other. Let's get a better one here. Like this one right here is in one spot, over here, back and forth. And you can clearly see space rocks everywhere in these photos. So this turns out that the Windows Photo is the best way to use this, and I sorted the downloads sorted these by name, so the time when they started. Let me get this. Get the where's that? We'll go back to the website. Here it shows the time. Like say this is the first photo right here, and you can take a look at the time it started. Start time right here. 6/7/2058. These are not in order, but I have a let me see if I can find the notepad that I just had open, where I sorted those by, if I open, yeah, the antenna data here. I sorted them by time, and you can see right here the from the first one to the second one, there's these are 300 seconds long, so that's what, 5 minutes? So they're almost right, they're only minutes apart. And that's good, because you can look in the photo and tell, just from going back, there's only a few minutes apart, that there's, you know, space rocks moving everywhere. Could be debris. You know, let me know your thoughts on that. It's like there's a spot right here. It's down here, back and forth. And that's good. You can actually, the James Webb Telescope, you can actually see these things now. And you can, and I don't know if they're cataloged or not, but obviously there's one. It's way down here and way up here. So it's moving quite fast. But there are other ones here. Let me see if I can find a slow one where it doesn't move very much at all. Let's see here. We'll scroll back and forth here. Anyways, you get the point. Yeah, like right here. This one doesn't move very much at all. It's just back and forth. Only a few pixels. But it's good that you actually can see it. So let me know what you think. And if you have a Python program that can combine these images into like a little movie, let me know in the comments if you know of a better way to do this.